So in the second lecture of today, we shall continue the discussion related to the behavior of the systems which we had just begun at the last leg of yesterday's lecture. We had introduced what do we mean by signals yesterday, and we are talking about what do we mean by systems. These introductory lectures are supposed to create a good feel amongst you, and they should enthuse some kind of interest amongst you. This subject requires own thinking like linear circuits, but in linear circuits at least we were observing some circuits, whereas in this case even we go at further conceptual level, so that there is no need to presume any circuit or physical arrangement as such. The complete things remain at a conceptual plane, and for such subject everybody of you should take a keen interest, and this does not require any other arrangement, so that I could not get the practical slot, components were not there. Such reasoning cannot be at least attributed to our limitation of studying in this subject. So merely it requires that you should have an analytical mind and exposure to the themes which have been introduced in the lecture, so that your own work should start. Your brain and mind is the laboratory setup for working on this particular subject. So yesterday only we had discussed that the amplifier which we are expecting to work like VOT is equal to 5 into VIT. This amplifier cannot be realized because of limitations of physical systems. So this equation is non-realizable. Then, because if it is to be realized, then we require instantaneously responding system, which we cannot get. Therefore, as an alternative or a realizable approximation of this ideal non-realizable equation was considered, and after such consideration, almost all of us have come to a conclusion that VOT is equal to 5 into VI T minus delta T can be such equation, to which one doubt was raised about the exactness of 5. Is it possible to get exact gain of 5? Then, even though that exception was valid, we right now don't consider the issue that is approximate 5 is enough for us at this moment. So except that, everybody of you feel that this equation is realizable, where delta T would be ideally 0, which we can't have. So for good systems, we should have small delta T. For average systems, we will be having somewhat moderate delta T, and for poor systems, we will be having a large delta T. So everybody of you agrees that this is possible? Yes? Yes. Or anybody who thinks that it is not possible? Merely because negation of the statement that it is possible, we should not say not possible. You should come up with some justification for your statement that it is not possible. What do you think? You think it is possible?
Sir, if a system is having feedback, then the previous output will also cause some.
If system is having feedback, so
then it will have.
Yeah, that is agreed upon. But for a non-feedback system, so right now we have not considered what kind of system it should be. But can this is equation number 1. We came to equation number 2 because equation number 1 is not realizable. Had this been realizable, there might not have been any need for us to discuss at length. Since it is non-realizable, what can be thought to be a realizable approximation of equation 1 is now being considered equation 2. And my question is very much pinpointed, whether equation 2, which is coming as a solution, as a realizable approximation of equation 1, is really realizable. It has been suggested by one student amongst you that this can be a realizable approximation, but whether that suggestion is correct, what do you feel about it? I think in some other context in the first semester also, we had deliberated on this issue. What do you think?
Loss inside the system.
What loss?
Practically, we can get the exact number.
Exact 5 we are not interested. There may be he is deeply thinking. As stated in the beginning itself, this is an analytical subject. Therefore, there should be a rigorous brainstorming within and amongst you. Now, rather than asking you to comment on whether it is realizable or not, I would like to answer the question and then expect a reasoning of that answer from you. That unfortunately, or we can say fortunately also, because had this been realizable, it would not have given any opportunity for us to study this entire subject. If equation 2 would have been a realizable equation, then hardly a scope would have remained for the subjects like signals and systems to be a subject matter of study. So, in what way you take it is an individual perception, but somehow one can say that this is also a non-realizable equation. This cannot be realized. This equation cannot be realized. Now the question is, why this would have been like this? What is a major impediment, major hurdle in realizing this equation? In various theories of proofs, there is a theory by contradiction. When we try to prove something by contradiction, the statement is not non-realizable, is the statement which is to be proved. So what do? We presume that it is realizable. Then, after presuming that it is realizable, we find out what would be the requirement from the system to realize this equation. And then we prove that this there can be no system which can fulfill this requirement. And since the necessary requirement for realizing the system cannot be fulfilled, our presumption is wrong and we cannot have such system. Now we are having recording is a different story. It records in a different manner. Actually, there is some digitization and all those things. But forget about that. You just think that if this recording was not there, I am talking something and you are asked to talk exactly the same thing after 2 minutes. Can you do so? If ever a system has to work like this, at a given point of time t, what the output should be? 5 times the, let us say we have a system for which I have delay of 10 nanoseconds, let us say for time being. A system with a delay of 10 nanoseconds. At every, this you just try to imagine the requirement of a system which it should fulfill. That at every time t, that amplifier must remember what was the exact input 10 nanoseconds back. That should multiply by 5 and produce the output. Then at immediate next instant, it should also remember what the input was at immediate next instant. So the system is required to remember the complete input for all the time in its entirety and has to work on that. And that is something which is highly impossible. Remembrance of a system cannot be in this way. It cannot remember everything like that. It cannot remember everything for every time. So that is not possible. So we cannot have a system whose output depends exclusively on input at a particular instant, may it be current instant, may it be past instant. A conclusion from impossibility of both of these equations can be stated to be, we cannot have a system such that its output at any particular instant depends exclusively on the input at any particular instant, either that instant or a previous instant or a future instant. Future we can't have, that will be predictive system, but even not current instant because of instantaneousness impossibility, and even previous instant dependency exclusively because it has to remember all. That is not possible. Then what is possible? An instantaneous system is said to be a memoryless system. But that can't be a practical system. So, even though memoryless system, which is said to be a zeroth order system, no system is memoryless. A system is there with memory. And when the concept of memory comes, it is defined to be state of the system. A system is able to remember something, means it becomes the property of the system. Even though input is not there, system finds itself in a state. For that purpose, we may consider two elements which are specific, or rather than one element which is a specifically memory element, that is a capacitor. Resistor, a voltage can be applied across the resistor. Current flows through the resistor, but the capacitor can hold the voltage and inductor can hold the current. Capacitor and inductor are two elements. We are not so familiar with inductor, even though there is no reason to be non-familiar, we are not so familiar. Same thing is with the PNP transistor. With NPN transistor, we feel that we are more familiar, even though we are not also there. But with PNP, we are not at all familiar. Same thing is there between capacitor and inductor. So, a voltage can be applied across the resistor, current flows through the resistor. But capacitor holds the voltage and inductor holds the current flowing through it. And capacitor can hold the voltage even if no input is applied at that point. So voltage is held by the capacitor, that is, capacitor has got a memory, and the form in which memory as such is a concept. It's not a memory is not a variable. Memory is a concept, and to materialize that concept, I need a variable. And for a capacitor, voltage is the memory variable. Capacitor can hold and can continue to hold unless not specifically discharged a particular voltage. A voltage across capacitor will not change on its own unless it is made to specifically discharge or charge through a resistor. So resistor has got only a value, 5 ohm resistor. When I describe a resistor with its value, everything about the resistor has been described. That is not the case with capacitor or inductor. Only describing value of the capacitor is not this complete information about the capacitor in a circuit. Along with the value of the capacitor, you must also state what voltage it is presently holding across it. So capacitance C in farads and voltage in the form of V or charge held by it, which is equal to C into V. So capacitor retains the charge and continues to hold a voltage across it. So voltage held by the capacitor is called as state of the capacitor. Every device has got a state. Again, state is a conceptual thing. In capacitor, capacitor has a state in the form of voltage across it. Similarly, inductor has a state in the form of current across it. Is it clear? Then, state is an outcome of what? State is an outcome of what? What? State is not an outcome of memory. Memory is actually state and memory are synonymous to each other. What will make capacitor to have voltage? Whether a capacitor is prepared physically by using the metallic plates, dielectric amongst it, and putting some oil to make it more dense and all that. Will it have voltage across it? No. So how capacitor will get voltage across it? So for that purpose, you will apply input. So current input is responsible for future states, and current state is an outcome of previous inputs. We are also having voltage is the input, voltage is the state. We can give current input also. Right now we are not interested in that. So voltage input, voltage state. So if we talk of a simple circuit then, like this, it is a very interesting circuit. I many times deal with this circuit. In this first semester also we had dealt with this circuit, and even though you had come up with some answers, you may not be still remembering how you have come to the answer and to what answer you have come. I enjoyed it immediately. Because it may be captured neatly. It is being seen there? It is also being seen.
Yes.
So what happens? Input applied causes some current flow. Voltage applied here actually. This is a system now. This is a complete system. And what is the output now? Output is the state of the system itself. We may have some an ideal amplifier we may have, but right now we don't want to put that. So we apply input and we get the output. What is the output? State is the output itself in this case. So we had started with amplifier and we have come here. So it's a very interesting question itself. Can you establish a relationship? It means even everybody of you is able to completely understand the relationship between input and output for this simple system at the end of the course, then also I will feel that the purpose of the course is satisfied. Because we had seen the same circuit, all of you have got satisfactory grades in linear circuits and networks. Those who have failed, unfortunately, of them, few have been able to pass in the revaluation. Despite, so there is only single failure, and many are having the grade like BC and CC, and still we are not in a position to derive the relationship between VINT and VOT. Still can you derive? You try to derive the relationship. Is it clear now? This system is given, so it is, we consider signals in the first instance yesterday. When we started with the system, in that there is a deviation, and this is a study of signals and systems, determining the relationship between VIT and VOT for this system is a complete example of the entire subject. In the system we have got system elements. For the system elements, do you have only one notebook? Oh, that's very nice. Oh, few of you might have felt that I am presenting in the diary. It is not. So it is just to hold the camera. Because presenting a diary is not a good exercise, because it may demand how you are maintaining that. So that is actually a punishment. Okay, anyway, so what is the relationship now between VIT and VOT? We have got a system which has got system elements. System elements have got their own properties. Like resistor has got a property. Specifically, I have taken the value to be 1 so that numericals become simple. Capacitor has got a property, its value is also 1. So what is the relationship now?
VOT equal to VIT into S upon S plus 1.
VOT is equal to VIT into something is not a complete answer at this stage. Your answer has got a major assumption which is not stated, and that is actually right now we would not like to do. He has elaborated something in S variable which itself is very complex in nature. It is said to be a complex variable, and really it is complex in nature to understand. It requires a class of signals like e raised to st. To that we shall come at a suitable time. So right now what we find is, it is a difficult question to establish the relationship between VINT and VOT. Because again we are interested in studying the behavior of linear systems, or actually there is a very specific popular term called as linear time invariant systems. Such systems will not allow a diode in them, because diode is a non-linear device. Whether capacitor is a linear device, my question is very simple, whether capacitor is a linear device, or to extend the question, what is called as a linear device? What is called as a linear device? Let us be very much focused as regards to the variables as voltage and current, even though that should not be a limiting criteria, but so as to make the thing simple, we try to make a restraint. We try to have working definitions. Working definitions are stated in non-classical words, but their purpose is that a student reading the definition should understand. And classical definitions are those which are stated in classical terms. And even though I will not say the purpose, but I can definitely say the outcome is that the students do not understand. So we will not be like that classical definition, a working definition. So voltage and current we consider. So what we mean by linear device? What do we mean by linear device?
There is a linear relation between voltage
And current. The linear device will have a linear relationship between voltage across it and current through it. So which is the most simple device which anybody can say without thinking much? That is resistor. Resistor is a linear device because V equal to I into R, or V equal to R into I, where R is the constant of proportionality. It's a linear relationship. Now for capacitor, does such relationship exist? Whether for capacitor, whether V is equal to C into I or 1 upon C into I, then what? How capacitor, or whether the capacitor is non-linear device? What do you mean to say? Linear device? Then does it exhibit the relationship, linear relationship?
Q is equal to charge into voltage across the capacitor.
Then?
And charge is nothing but the product of current and the time constant.
Right. So there is a linear relationship between voltage and charge, where charge is related to integration of current. Or if you differentiate it, differential of charge is current and then it is differential of voltage. So we can consider a device to be linear if voltage and current, voltage across the device and current through the device are linear in terms of themselves or their differentials. Obviously integrals, because difference is enough. Are you getting me? A device which exhibits a linear relationship between voltage across it and current through it, either in direct form or their differentials, is called as linear device. Therefore capacitor, for which we are having I is equal to C dV by dt, and for inductor V is equal to L di by dt. Therefore both of these are linear devices. And therefore if we try to establish some relationship between input and output for this, we have to take help of a differential equation, and after taking help of a differential equation, we are in a position to solve the differential equation, and we really get a relationship between V in T and VOT. Now my question is, what is that relationship for this? What is that relationship for this particular system? So did you get the answer now? See, this question is the question in the second lecture in the second semester, with the background that you had successfully completed the first semester with a course of linear circuits and networks in it. So you got some answer?
Exponential relationship.
What is that then?
Is equal to 1 minus a raised to minus t. There is exponential decay.
VOT equal to?
1 minus a raised to minus t.
No, that is if you are having, you are answering V0t for a particular V in t. So system is now fully known. Input is not known. Means it's a general input. VIT is a general input. Fully system is known. So when system is known, we have a general input. The output would be taking a form which will have the input as a term in it. Means output would be in terms of input. The output equation will contain VIT. If you know VIT, if you know the system, then it would be a complete output directly available as equation. If you know the input, don't know the system, then the output will contain the system component in it. So input, system, output. If both are known, a specific output. If one is known, the output is in terms of the other unknown. Input, system, output. Right? So now the question is how we describe the system is the question. Have you learned convolutional integral? Can you solve? You must have gone for solution of the differential equations. So what is the solution now? The answer is like this. Is in other ways stated to be a convolution of output is an integration of v in tau e raised to minus into bracket t minus tau d tau. So it is I will explain what convolution is in detail. It is a convolution of these two. This is now called as HT. HT is transfer function e raised to minus t in this particular case. HT is equal to e raised to minus t in this particular case. So it is output is a convolution of system and input. So the homework for you is to come to this solution by using all your mathematical knowledge before up to differential equations. This must be arrived at. So we got a deviation. Now we have to return suitably to the main flow by having a overall understanding about the deviation itself and the main flow. So this, if you look at this integration, V in tau, you multiply by this, for 0 to t. Can you imagine this? How the multiplication is at a given point t? At a given point t, how the output comes? Let us try to plot. It's quite interesting. So let us have input like this. This is input. V in t and this is t. At a particular t. So here you want to find out what is the output. So at this t, it is integration of what? Integration of Vi tau multiplied by e raised to minus t minus tau. So e raised to minus t minus tau is plotted as like this. At a given t, e raised to minus t minus tau is plotted like this. And these two are multiplied. These two are multiplied. Area under their curve is found out, and that is the output at this instant. VOT here is area under, you can, those who are somewhat smart in programming can prepare a simulation for this. So it's actually not simulation, an animation we can say. These two curves are multiplied. The multiplication itself is a curve, and area under that curve, and that is the value here. Actually, it is smoothing effect. At the beginning only I had stated that this subject is analytical in nature. Because of its analytical nature, it will require instantaneous attention of every individual. Even though the help of recorded lecture is available, that is not to be used as an excuse to deviate the attention. So what we can say, the output at this point is dependent upon this and this, their product. Means input now to some extent, input previous to some other extent. So what I can say, if I discretize it, I may understand somewhat easily, which we can do. So we can say, I quote, the output at a given point of time is nothing but the weighted average of actually all previous inputs, but the weights are usually such that those go on reducing for more time. So we can say practically the output at a given time is weighted average for some previous duration. I mean, this is some, actually it is all, but for practical purpose, some previous duration, and it is weighted average. As a weighted average, it is not plain, it is not dependent upon all the inputs in previous time with the same proportion. It is like a human feeling. Suppose if I fail in FE part 1, I am very sad. Those who might have been there might have been very sad in January 2011 because of the failure in FE part 1. But in April, are you so sad? No. So our state depends upon the events which had occurred in the past, and obviously the weights for the events which had happened just now is more. The weights for the events which have occurred somewhat earlier is less. So for a system, the output is the weighted average of previous inputs. And then what is HT then? HT is a transfer function. It is like this. If you plot HT, it is like this. It is just mirror image of HT. It is HT versus T. So what HT is? HT indicates the proportion with which the input which has occurred T time ago is responsible in determining the current input. Right? I again repeat. HT is the proportion with which the input which had occurred T time ago is responsible in determining the current output. So HT indicates the role of the input arrived T time ago in determining the current output. So what we can say, current output is a collective phenomenon of the inputs arrived in the past. It doesn't remember everything in the form which was required to be remembered if equation 2 was realizable. So state is a single dimensional variable this time. Memory is single dimensional. An individual's memory is multi-dimensional, infinite dimensional. But for capacitor, for such systems, it's a single dimensional memory. So previous inputs form the state. It is just an inertia effect. As time proceeds, previous effect slowly dies down, new effect is added, and this system functions as a whole. So this device, this system is specifically made to be a low pass filter in which the system is supposed to smoothen the input. So smoothing effect here is by design. Well, an amplifier is not supposed to be a smoothing system. Amplifier is supposed to amplify. But since instantaneous response is not possible, an amplifier also has got a transfer function which is a very steeped exponent. Means this is why? Because it is a filter. For amplifier, it should have been like this. Ideally impulse, but practically a very high value exponential decaying curve. So for amplifier also, the output depends on previous inputs, even though it should not have depended. Therefore, for amplifier also, the output is convolution of input and the system function. The ideal amplifier system function must be an impulse, and practically it is just like a very high value exponential decaying function. So from these two sessions, I suppose that those who are sensible must have understood what would be the nature of the subject would be. And you will be preparing yourself to work in that direction. So this subject requires reading as well as thinking. You are not in such a stage where you can think without reading. Therefore, reading is essential. And read without thinking is of no use. So, thinking and reading should go hand in hand so as to have an effect where, and as I had always stated, it is a fundamental subject. It is required for every engineer. It has applications in all disciplines. It is a discipline independent to that extent. And you will be able to understand the significance if and only if you have understood the subject. Means it is such a thing, just like what I say, that the laser operation of a person who is blind from birth, the significance of the operation cannot be explained without operation. So significance of learning this subject cannot be explained without learning. Therefore, just that the patient believes the doctor and gets operated and experience the change, I appeal to all of you to study this subject by having faith in the teacher and then experience the significance. I hope it is all. Today you are having economics lecture, will be there? Huh? Who? Why? Why no? Today? So what is the 115 lecture? No. Yeah, there is minor change now. So today and tomorrow, Wednesday and Thursday, since your body clock is not able to adjust for a lunch, so we are having the duty cycle based extension. So on Monday, Tuesday, lunch at 1:15, on Wednesday, Thursday, lunch at 12:15, and on Friday again lunch at 1:15. So today and the new time is put up, as the economics faculty is a visiting faculty. In order to adjust the timetable for that faculty, there is a minor change. So today, now there will be lunch break, and at 1:15 economics lecture is there in the timetable. And if for some reason it cannot take place today, then our arrangement holds good that you are supposed to call me. Recording off.